Two, I'm going to talk about routers. I have to talk about routers because we're in a situation. Routers are basically in the process of being completely banned, but there's always reasons people have to have routers. The problem here's what the problem is: we don't have American manufacturers manufacturing consumer routers, only industrial ones. They're expensive, so they want to ban all of these little consumer routers because they're all made abroad and the Chinese are getting access to them. Now, you need more truth than that, right? You need the raw truth. So I've studied these type of situations. This is, this goes into electronics. This goes all the way back to the Reagan administration, where you had people talking about the design of chips and backdoors in chips. So the main problem is you have people that want to design chips so that they can get inside to spy on you. The problem is eventually that backfires. That's what all the tech guys said. Here's the formula of physics right here that you go by, and eventually you only have a certain amount of time until you get to failure. Now, you got a lot of guys that are trying to find ways to talk about what's going on without necessarily always telling you exactly what's going on. So we now have quantum computers, and quantum computers are getting cheaper and cheaper. So we have the quantum computer capability that can decode any type of code system utilized to get access into the back doors of those secret operational areas of all chips. So we have a guaranteed catastrophic failure factor that keeps reoccurring again and again and again. And this is why we have mass attacks. Now, my designs on chips prior to the year 2000 deal with a multi-stacked chip system where you have a lot of these different chiplets and all these other things. A lot of people didn't even know what chiplets were. This is really interesting what's in my archive. I've had people before that looked at samples and said, "You're talking about this back in 19 and it wasn't invented yet, and you're talking about." It says, well, it depends on your opinion. There are different people who, we're talking about standard evolving quantitative logics. So you would have scientists that would discover the logical evolutionary pathway courses. So this is when you find these types of information that would be rare today, where people are studying different things, and they came to the same mathematical conclusions because mathematical evolutions generally follow similar path lines. So this is why you can end up finding people that have papers that have written about things, and you go, but that's not a public paper. Gee, it works that way. Hello, how are you? Anyhow, so you have the quantitative logic situation. We know it all the way back since basically Ronald Reagan about these various problems that we have to deal with, and it's a trade-off. People, I'm going to tell you straight off. Do you want to monitor crazy terrorist people? That was part of the thing. You have to understand that originally it was a brilliant idea to say, hey, we're just going to build right into the chips. We're the number one chip manufacturer in the world. We'll just build these special backdoors and mechanisms and extra secret modems and devices and all this neat stuff right into the chips. So right now we have too much of a breach problem, and we have the massive quantum computer factor, which basically means that we have very poor security structures respective to certain types of handling. Now, your end user device can do different things that's supposed to be able to protect itself, supposedly. But you have the same type of engineered backdoors in your chips. So the solution that I came up with is very simple. It's the same thing that other engineers came up with. To eliminate the backdoor problem means you eliminate the backdoor. This means you have a multi-stacked chip that you make, and it has a parental level that is firmware. It's permanent firmware. In other words, it's not flash firmware. It's not a BIOS chip you can reflash. It's permanent. The reason you do this is you want to make sure that the original design mechanism, the parental control systems and parental main programming, can never ever be interfered with. So the only way you can deal with this is by having an extra chip sections that you can add a new chip to, and the chip is a firm chip, and it has, well, even software in it. What is software is converted into firmware. So, running the firmware means if you do it proper, it's not a BIOS chip. You can't reflash it. You can't update it. It's not updatable. You have to change out the chip. So it's not updatable, but there's something else that comes with it. It's impenetrable. There are no backdoors designed into the chips or into the programming. Therefore, you can't get into them. But then you would, of course, have ultimate privacy. And that would be for anybody using the device. So if you were a terrorist or a foreign spy, you would have a device that nobody could get into. It wouldn't do anything unless you allowed it to occur. So this is the solution ultimately. Why is it the solution? Because quantum mathematics are moving so fast now that it's not possible. It is no longer possible to protect backdoorism. Can't be done. So, you have people that say, oh, we'll just come up with this longer string of numbers and this and this. It gets ridiculous. But I don't want to go into the full quantum reality communication ecosystem to explain that it's all over with. It's ended. It's impossible to basically make chips anymore that have backdoors in them and not expect that the backdoor's not going to end up getting affected. Now, what the systems have been is they upgrade you. They upgrade, they reflash it, or something to change the doorways so it's a different type of coding system. These are what's known as temporary stopgaps. They're changeouts. Now, you can do a lot of them, by the way. You can come up with a really numerous set of predetermined understanding of codes and keep them in lockdown. That means you can never share them. They're at the manufacturer. You can't share them with anybody, ever. So what you do is you then put out these different codes periodically. You send them physically. In the mail, you get a hold of a chip that has your next set of codes that are good for like the next 30 days. It's similar to what they used to do with some of the video situations for cable decoding. Except, that can work somewhat well. But the thing is that there are still limitations on that. People can still come up with what I previously said with mass quantum computational break-in science. So the only way to stop this is to say you want an absolute private chip, that you want an absolute no backdoor situation, and that you want all of your basic mass categories of software to in fact be firmware, because that's the only way you're going to stop the fire. I'll tell you right now, that's the only way you're going to stop that fire. So this means that A, the correction is expensive, and B, we don't have any infrastructure really building it. We've got some at an industrial level, but at a consumer level, it's like zero. Now, some stuff's coming out of Taiwan and some of these other different countries, and it's interesting. It's not that it can't necessarily be achieved by certain companies, but the current philosophy in the economic system has not afforded that. So we have to build the solution is building a new series of chips. And that means building a new series of manufacturing styles, completely different. AMD's come out with the multi-stacked, and I believe NVIDIA's too, chiplet type system, multi-chiplet systems. But still, we have to do this for routers, basically. But routers are rather simple. It's kind of like a repeater. It comes in, it echoes around, it's re-amplified and retransmitted. Okay, a repeater. It's a node. It's a repeater. These are your routers. So, but you can do far more elaborate things now with routers. But the thing is you have to figure out what you want to determine is the actual access capability, and that is a physical tap plug-in. You don't want to be able to remotely tap into it. You have to physically get into it. That's a separate line. That's a dedicated localized separate access. You can't really do remote access because then you're using codes to enable remote access, and all of those can be overthrown. So here we have basically a system that we put in place that will work, but you have to convince people to say, in order to do this, you can't allow communications of governments that want to watch spies or spy on you. So this is something that mathematically it's the only way to do it. It's the tactical table. There's only so many mathematical options. So into this, there are other things that you can do, by the way. You can do these different multi-layers where you're able to detect things like certain types of cyber attacks. You can measure these nanoseconds, and you can cross-coordinate and be able to see the origins of certain types of cyber attacks, and even certain types of orders where parties would be sending things like orders for algorithmic isolation, stuff like that, state-sponsored stuff, and the kind of stuff that California is using to rig elections right now. So these things could be detectable. It's not that hard to incorporate them in a new style of chip understanding, respective to being able to immediately track down and get you the source of your cyber attackers. And some people talk about how complex it is. Well, you'd be amazed how much of it has certain other signature items that are not as complicated to detect as you would think. So you're measuring the nanosecond differences, and you're going to triangulate to where people are. That means you're going to locate these big, huge black buildings that have mass amounts of cyber attacks in it. 1.2 trillion dollars a year in damage being done is not coming from a couple of kids in a garage playing with computers, and it's not coming with one person that fired up a laptop. Although the way certain repetitive systems work, they're with some of the router systems designed, they can effectively do certain things. But you have to eliminate that. Again, the reason that they don't work right is because they're designed to have flaws built in. You have to stop the built-in flaws. And you have to understand that you basically, you can look upon it as just using like some of us would use it. It's just a repeater, and it's going to have poison running through it perhaps. So you have to make sure that your end devices have another special system to protect them. Kind of sort of that works. But again, if you have certain key backdoor codes, all bets are off. So we have a master problem with all chips that are manufactured, and it has to do with government oversighting that wants to have backdoors into your chips, which means you permanently have idiots that think that they're going to be able to maintain security, and they don't understand true purity tactical table warfare tactics, in which we just take that. We just take that, and we're going to hand you your hat real quick, guys. Oh, you're all security professionals. We're going to bend you over fast. No joke here. Okay, so we've talked a bit about the routers. Okay, so we're continuing. So in order to protect national security, we're at a realization point that these other people's personalized whims that, they want to do algorithmic isolation, electronic kidnapping, imprisonment, and rigging of elections, we have to stop that. And all of this business is saying, well, we're going to have to be able to have backdoors to read all terrorists. Well, unless you're going to make special dedicated chips for that, we're no longer going to do a mass quantitative continuing mathematical policy to force that into everyone's hands, because it's too much of a problem. When I'm doing certain types of national security research, I can't have Bozo the Clown think that he just came up with the next set of quantum codes that were discovered by a quantum computer in China, and they want to run around and get into the back door of my business. This is why we're at catastrophic failure, and the government doesn't want to admit it. This is where you have the difference between the men from the boys and the type of design systems that have to occur. So we're going to have to put a permanent stop to these design systems because of new quantum computer sciences. Because we're getting into that level where we're going to start being able to work with some really neat shit. And that is to say, quantum resonance echo sciences. And this is something that many people don't understand about. Something that I basically, as far as I know, some of the stuff was completely my discoveries in my labs, working with certain stuff. So this is something where there were certain people that were allowed to see certain things. You have certain agencies that I allowed to see certain activity if I was going to connect to certain things. There was other stuff that I don't want to talk about how the private access had a share, basically for key government, U.S. government personnel only. But it's a part of a lab protection system. So, it's fragmented. It works different ways. So, we're at these mathematical doors where we have to make certain decisions, and the decisions that are logical on the tactical table is we have to jump to a different type of a securative system. That means we have to jump to a full quantum aperture technology. That's the only way we can be able to still monitor certain things in terrorism while affording people an exact protection on their chips. That means we're going to have to start manufacturing chips that will no longer allow government or anybody to affect your device whatsoever. In theory, but it doesn't. There's almost no such thing as a device that can't be affected by resonant quantitative echo technologies, basically. This is the resonant weapon systems. So now we have the Chinese working on it on a large scale, and we're way behind technically. We're way behind in the U.S. We got to throw big money into it. And we have a lot of people, they just want to keep playing these really ridiculous dumb games in politics. They want to keep being clowns throwing around peanuts. They don't want to reactivate the Constitution at its full power state. They don't want to restore the middle class. They don't want to make America great again. Because there's some of us, can we please make America great again? Let's do this. And so we have to do these certain things as of key importance to understand when you get to these certain points of logic why certain things have to be a certain way, why we have to have a trust in our own citizens, yet verify certain situations. That means that we've got SAR, we've got synthetic aperture radar. That means we see a blade of grass. This is recorded. We're pretty much recorded in full 3D in many places around the world. Southern California is one of them. There's so many overlapping satellites and stationary satellites utilizing the technology. We're basically in full 3D at any given time, recorded. It's a radiographic ecosystem. And so it's something that is just happening. So we have massive violations of elections being recorded by SAR satellites, particular in California. Massive supportive evidence of certain actions occurring. We have massive, and what happens is you have massive verification at what level one? Level one, mass dereliction of duty. In other words, people are under attack and they do not want to respond properly, and this is recorded by SAR data. So when you're working with high-end professionals that have signatures of understanding that certain people are doing things and certain things are going on, and then situations don't have certain types of reactions the way they're supposed to, well, what ends up happening is you have an automatic analyzing system that's ongoing. It's always running, and it sees that there's a problem. I can't emphasize how many people in the military are utterly disgusted at how many times they keep running into. Whoop, we got a red flag. What's going on? Oh, well, the automatic. This trip. We got another tripped. Red flag. Here we go. And they're looking at it, and it's like, wow, we're catching politicians committing treason again. This keeps constantly happening. Well, where did they get that? Well, we designed the systems to give us ultimate intelligence when we're looking at foreign governments. But once you essentially build the software, you're going to basically keep all the goodies and bells and whistles in it. And of course, we also have firmware. This is another thing people don't understand. We build certain custom chips, and they are firmware. There's no reason to have a backdoor in it because it's ours and we control it. So these things work certain ways. So there's a problem. The problem is that people are furious in the military. I'm not kidding, because we have all this stuff that the satellite is basically going around the planet. It's grabbing high intelligence. It comes around, has to end up going over the United States on a pass. And all of a sudden, the automatic evaluating systems are coming up, boop, 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 because it's equating all of these different complex mathematical cogs in certain places. It captures the data. The data is resorted based upon blocks and certain interest and random checking and different stuff, or individual focus design. And of course, we have mass capture of all the data to begin with. We always have the data. The data is there. We can rework it at any time. So, but we do have these problems. We're trying to provide security for our own people, and then we catch them. I mean, I don't know if this clicks in people's heads. You got people in government. Yes, we want security. Great, we have the best security ever designed. We're recording everything in full 3D. Everything. We got remote sensors at long distances. We had helicopters in the 80s. We had helicopters in the early 80s that had the ability to hear you whispering in the middle of a skyscraper as the helicopter could be hovering outside the skyscraper. I don't know if you understand the sensitivity of something like that. It can record what you were saying through concrete walls and everything. You're talking about incredible different levels of technology. Then we got ELF levels and this other stuff. You just wouldn't believe some of the things you can do. It's mind-boggling, And of course, we have the great Carl Sagan. He walks across the dish. He records his biological radio signals. Carl Sagan, so I don't think people actually understood who he really was. Because when Carl Sagan was going to help national security intelligence, he was instrumental in proving biological radio reading from remote distances. This guy could work deals to get basically science going that would be able to read your brain from 500 miles out in space, because we wanted it to use it to read the Russians. So he was, Carl Sagan, he's a god. He's an intelligence god. He helped to bring about the end of the Cold War, and people have no idea. They'll have no idea of what Carl Sagan did. And Carl Sagan died of cancer. He died because he risked his own life exposing himself in these custom lab tests and walking across radio telescopes, across the dishes, recording his signals. He ended up killing himself. He's a hero. And most people only know him for his NASA or his liberal side or this or that. They have no idea what he did respect to deep intelligence, for our intelligence, for our national security of this nation. An incredible individual. Anyhow, so I started talking about the on this section, the hub system. We're going to have to make new chips. We're going to have to make a lot of different changes. We're going to have to accept a lot of different realities. It's going to be a big technological jump. We're talking about mass upgrade of chips yet again. So we're forced into another mega investment in boosting electronic chip technology, literally. And we're going to have to do another one and another one and another one. And we got different types of other chip technology we need to boost as well. There's a lot of stuff. It's really complex. So ideally, we're going to want to create a series of new types of super chips, basically for routers to be able to assist us running remote Wi-Fi operations from tiny drones that will basically be able to be on call boxes on freeways and on telephone poles and power poles, so that we'll be able to have an independent operating system that is uninterruptible. It has to be an uninterruptible service system. That's what we have to do. So that if we have earthquakes and emergencies, we cannot also have parties that bring us under electronic attack. So we have to have this. We have to get prepped for it. We have to design for it. This is what we have to do. These are the next evolutionary stages that we're stuck with if we're using our brains. We're just basically stuck with them. So we have to do this. So we have to move forward. And 26 minutes in. Okay, I'm going to end this right here. I'm feeling a little better, and I'm going to go for my second cup of coffee.